Earlier in this chapter, we learned how to solve right triangles. We learned how to find missing measurements when we're given maybe a right angle, an acute angle, and a side, or a right angle and two sides. In this lesson, we're looking at how to solve any triangle. So we can use the law of sines or the law of cosines in order to do that. And when you're using law of sines, don't make yourself crazy thinking, oh my gosh, this is a hard formula to memorize. Think of it in terms of the sine of an angle over the side opposite it equals the sine of another angle over the side opposite it, and so on. For the law of cosines, very much the same thing. Don't make yourself crazy trying to think of it as a hard formula you have to memorize. Think of it as, hey, this looks a whole lot like Pythagorean's theorem. And then I'm subtracting something away from it because it's not a right triangle. So notice the relationship between the measurements in the equation. Notice how this side is the same here. Also this one, that guy's here. And this angle is opposite this side. So let's see how these properties get used. In the first example in your notes, we have two angles and a side, and I'm trying to find the two missing side lengths. Okay? So 62 is opposite 16, so I know the sine of 62 over 16 will equal the sine of, well, the angle opposite the x, they didn't give me. But if you remember anything from geometry, I would hope that you'd remember that the three angles of a triangle add up to 180. So 30 plus 62 is 92, and when I subtract that from 180, I find that this angle is 88. So the sine of 88 over x. And then it's just a proportion, so cross multiply to solve it. X times the sine of 62 equals 16 times the sine of 88. And in order to solve for x, I'm going to divide both sides by the sine of 62. And so I get my handy-dandy calculator and make sure that it is in degree mode. Remember, I've said previously, most of the graphing calculators out there will default to radian, so you want to make sure to look at your mode and make sure that you're in degrees. Okay, so what I'm typing into my calculator in order to solve for x is all of this. So I have 16 times the sine of 88, close parentheses, divided by the sine of 62. And that gives me 18.1 approximately. So the value of x is 18.1. And now we're going to do pretty much the same thing in order to solve for y. So I can recycle this ratio. So I'll have sine of 62 over 16 will equal the sine of 30 over y. Again, it's just a proportion, so you cross multiply to solve it. Y times the sine of 62 equals 16 times the sine of 30. So when I divide both sides by sine of 62, I have in my calculator 16 times the sine of 30, close parentheses, divided by the sine of 62, and that gives me approximately 9.1. So the value of y is 9.1. And that's how you use law of sines. Law of cosines As you saw, the equation is a little bit bulkier and more cumbersome. Also, in these particular diagrams, or in these problems without a diagram, I should say, they're not telling us where the A, B, and C are. Remember, the A, B, and C are opposite their corresponding angles. All right, so let's draw. And it doesn't need to be accurate, it's just for reference. Okay, so AB is 7, BC is 10, and the measure of angle B is 80 degrees. Okay, so this is little letter C. This 10 is lowercase a, and this is lowercase b. So the side that I'm trying to solve for is B, so that's going to be all the way on the left by itself. So B squared is going to equal, I'm going to write the whole equation out without any of the numbers first. Okay, so B squared is going to equal A squared plus C squared minus 2AC times the cosine of angle B. So let's let's plug everything in. B squared equals 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of 80. Let's simplify this. I've got 100 plus 49 minus 140 times the cosine of 80. And I'm going to warn you here. Here's where a common mistake happens. Put your pencil down. Common mistake I see students do is combine those three terms. You are not allowed to do that. That 140 is attached to cosine of 80, making it an unlike term to the 100 and the 49. Okay, so I've got 149 minus 140 times the cosine of 80. At this point, you should be able to type everything directly into your calculator. So 149 minus 140 times the cosine of 80, and B squared is approximately 124.7, which makes B approximately 11.2, which is what I was asked for in example 1. You may want to pause your video to make sure that you've copied everything down, because I'm going to have to erase it all in order to get example 2. In example 2, I have triangle QRS. Let's draw the diagram so we know what's where. Okay, so QR is 31.9. RS is 25.2. And QS is 37.6. This time, we are trying to find the measure of an angle. Remember that the angle in the equation has to be the same letter as the equation starts with. So, if I'm finding the measure of an angle R, I'm starting the equation with segment R. And again, I'm going to write the whole equation out without the numbers plugged in, and then I'll plug the numbers in, and we'll simplify and solve. So it'll be r squared equals q squared plus s squared minus 2qs times the cosine of angle r. Now we plug the values in. R is 37.6 s squared equals q is 25.2 squared plus s, which is 31.9 squared, minus 2 times 25.2 times 31.9 times the cosine of r. And again, make sure that you're being careful about what's like terms and what's not. Okay, so simplifying, 37.6 squared, 1413.76 equals 635.04 plus 1017.61 minus 2 times 25.2 times 31.9. That is 1626.9 times the cosine of r. Whew. Continuing to simplify. Again, I can't stress this to you enough. Put your pencil down. These are not like terms. You can't combine them all. What you are allowed to combine is this. Okay, so pick your pencil back up. And let's combine those two like terms. So 635.04 plus 1017.61. Okay, so 1413.76 equals 1652.65 minus 1626.9 times the cosine of r. Now I got to get my variable by itself. Don't forget the algebra you already know. I'm trying to get r by itself. My next step is going to be to subtract this from both sides. So when I do that, I've got 1413.76 minus 1652.65. So negative 238.89 equals negative, be careful, 26.9 times the cosine of r. Next step, in order to get the angle by itself, is to divide both sides by this number. So when I do that, I have negative 238.89 divided by negative 1626.9. And now I have that the cosine of r equals 0.1468 approximately. Remember that I have told you that the fewer times you clear your calculator, the better off you are. At this point, since I'm trying to find the measure of an angle, remember what we did way back at the beginning of the chapter. We use the inverse function. So if you're using one of my graphing calculators, if you notice at the very, very bottom of the calculator, above the negative sign, you're able to bring up your last answer. Okay, so inverse cosine of my last answer, which is that 0.1468, blah, blah, blah. And I find that the measure of the angle is approximately 81.6. So the measure of angle R is approximately
81.6